In this video, I'd like to show you something very interesting about the eclipse, and perhaps it doesn't work the way that we've been told. You be the judge. I'll just show you what I found, and you decide. But here, this is a light simulator. It's called the ray optics simulation. And this is a light source, a simulated light source, and I have a ball here, and or circle in this case, and an arc, okay, and the arc is much larger than the circle. Now, as the circle's close to the arc, you can see that the shadow sort of approaches the size or the width of the circle, right? And as I move the ball away, the shadow gets larger, and it looks something like this, right? And then as I move the light source away, the shadow gets weaker, but the shadow gets more narrow, like that, right? Um, let's see here. Let's see if I can zoom out some more. Maybe drag this down here, and I can show you what happens as it gets farther and farther away. See, the shadow gets weaker, right? Like this, but it doesn't get any more narrow than the object for which the shadow is being cast. Okay, so with that, I want to take you to the Earth and Moon. Okay, so this is the Earth and Moon down here. All right, let's see. There we go. And this is an engineer scale, and the way an engineer scale works is it it basically get breaks units down into smaller pieces, so everything's consistent. Now, the Earth is about is measured in one of these units here. Maybe you can see that. Okay, and it's pretty close. All right. Now, 30 Earths away, that's how far the Moon is, and the Moon is right down here. Right. So this is a scale representation, perhaps, of the Earth and Moon, the way we're told, right? So now the question becomes, how far away is the Sun? Now the sun's pretty far away. Okay. Now if I were to put this diagram here, if I were to put this on the touchdown line, the 0-yard line, and this Earth would be inside the end zone, let's say, how far away is the Sun over this way, perhaps, from the Earth, or from the whole thing? How far away is it? How big is it? You'll find at this scale it's about at the 75-yard line, and it's about 2.5 feet in diameter. Okay, now to simulate this eclipse, now I'm gonna do that, but again, like every other eclipse model, I have to adjust the ratios of the distances and things like that. But this is showing the Earth at about 7,900 miles in diameter. It's pretty close. I rounded. The rounding doesn't take the away from the point of what I'm trying to show here. The radius of the Moon about 2160. All right, and what we're being told is that the shadow cast on the Earth from the Moon is smaller than the Moon itself, and that the light bends in this sort of weird way to where the shadow kind of comes down and sort of focuses down. It either crosses over or comes in. Either way, the solar eclipse, the most recent here in the United States, casts a shadow about 70 miles wide. Okay, so that's where I got this number here. And you can see it's smaller than 10%, or 1/100th rather, 1% of the diameter of the Earth. Is very, very tiny. Okay, so we'd expect the shadow to be no smaller than 2160, but we get 70 miles here. Okay, which is very fascinating. But we have a ratio to work with, and that's a good thing. Okay, so maybe it works this way. That's fine. But if it works one way, it should work another way. So we should be able to get a ratio, because if we come back to this diagram here, if we have the Earth over here and the Moon over here and the Sun over this way, then the shadow being cast over here on the Earth should be no different than if we have the Moon here and the Earth here and the Sun over this way, and the shadow is being cast on the Earth and the Moon. Okay, so all the ratios should work out, right? So we have 70 and 70 divided by 2160. What is that number, right? That's a good question. So I've done that for you, and it's up here like this. Okay, so there's 2160 and 70, and you get 0.03241, right? 0.03241. Okay, and if you take this this decimal here and you multiply it by the diameter of the Earth, that means that the shadow that we should see on the Moon is 256 miles wide. Okay, so here's our Moon. All right, so what we should see is the light bend, at least in a similar sort of fashion, down to the Moon at 256 miles. So the challenge is that the Earth covers the entire face of the Moon, and so we should get a shadow that's 2160, but we don't. We get a shadow that's 256, which is significantly smaller. I think it's 11%, and that would mean that our lunar eclipse would look something like this. Now I drew this to scale, also, so decent scale. I mean, 10%. We could fit 10 of these probably in here like this. So this should be the transit of the Earth shadow in front of on the Moon. It should come in real nice like this, and we should see it transit across in a given period of time, which we don't. What we do see is we see an arc that is similar in fashion to the Moon arc, right? And what we should really see, if it works the way that that the light simulator shows, is we should see a massive arc like this, maybe, for the Earth passing in front of the Moon, because the Earth is significantly larger than the Moon. So, hey, if I'm not working this out right, I mean, I'm happy to hear all about that. But if I am, then why aren't we seeing the eclipse like this? This is how we should see the eclipse, according to the 70 miles from the solar eclipse, right? So that's how we should be seeing it, but we're not. How can they work differently? It doesn't make sense to me that they could work differently. If it works one way, it should work the other way. And every other shadow that I've ever experienced, the shadow is always the same size or larger than the object that's creating the shadow. Maybe I'm missing something. Maybe it's this magical gravity that's pulling the light in different directions. It doesn't really make sense to me that it would bend so significantly, such that in such a relatively short distance, which is a relatively short distance, that relatively short distance would distort the light so much that it would make it 70 miles. But then the Earth is bigger, right? So the Earth is bigger, has a bigger gravitational pull. So then what we should see, if that's the case, if the Moon is able to deflect light down so that the shadow cast is 70 miles, that there would stand to reason that the Earth would bend the light even more, and we would get a shadow that's even smaller than 256 miles. So help me out here. Where am I wrong? What am I doing wrong? Maybe I'm just totally missing something. And if I am, I'd love to hear from you. Leave a comment below, and maybe I'll see you in another video. Maybe I'll make another video in the future. Bye for now.